Hello, it's me, and I'm going to address a couple of viewer questions. One, this is from Mushy98. Hope I'm pronouncing that right. Anyway, had some issues with edge pairing when it came to this 5x5x4. So what he apparently had, and I tried to get this in pretty much the configuration that you're talking about, but what he did is managed to get all of the white side. Now mine is the black puzzle, so I've got white instead of black. I think yours is white, so I tried to make this look exactly like that. But basically, it was on the step where he got his centers, it looks like. Centers here, and he was trying to do edge pairing. And what he had is he had apparently all of the white edges that were fine. You can see this here, see this here, see this here, see this here. He was working on the yellows, and he got maybe this one, this green one, and for me, this yellow one. But he just had two more left. He had I believe it was a red and a blue, where you just had to exchange these pieces over here. So, how do you get out of this one? Well, luckily it's pretty straightforward, but what you need to know, the only algorithm you need to know, and it's nothing new, nothing that I haven't gone over before, this is pretty much going to be a middle swapping algorithm. Because the way that you're looking at this, the way that I do this, is you kind of ignore these parts. You ignore the terminal ends here, and you're just focusing on these three. And if you're doing that, these are edges and these are corners. And we're rolling these together. And if you look at it like that, then we have a similar situation to what you have over here. Now in this situation, we're going to do an adjacent edge swap, and that's the only algorithm that you need to know. There's opposite edge swaps. In the tutorial that I had with this, I believe the only situation that we ended up with was an opposite edge swap. Turns out the one that you're having trouble with was the only one I didn't go over implicitly, which is the adjacent edge swap. What that is you take the two edges that you want to swap, put one in front of you, one to the right, and then you do the algorithm 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. And that will swap that and not affect anything else. In essence, that's what you're going to do. So here's what you need to do in this particular situation. Take all of the edges that you swap that are the same color and just make your cross. So here's white. So what I'm going to do is I'm just going to put these in appropriately. So this comes over to here. Here's a white and red. So double turn this down over here. So that's where it needs to be. And now this orange and white is going to come down over here. So my purpose of that is make sure you have one solid cross on one side. And then what I do is I focus on the edges just on the top layer and do it based on 3x3x2 type of algorithms. You want to be in it? All right. Say hi, Jessica. Okay, so there you go. So basically what we want to do now is get that same situation that we had over here between the two. So I pulled this up here, and what you're going to want to do is put them so that they're next to each other. And in essence, what I'm going to be doing is I'm going to be doing edge swap, a middle edge swap. Now when I turn it, instead of turning it just from the end over here, I'm going to be turning it from this over here. So whatever you want to swap, that's going to be the one that's going to be in the middle, and you're going to be turning these as one. So what I'm going to do is we're going to just basically do an edge swap. Now, bear in mind there's something that's going to happen as I do this edge swap. When you do an adjacent edge swap or adjacent middle swap, however you want to call it, it's going to create parity along these two. So after doing that, we're going to end up having to get these back in. So here's what I want you to do. After you put these next to each other, moving this as the R, do that same algorithm with this as the R. So 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. What that'll do is that'll effectively put in your edges over here. So really what I did, and this is going to be important as we do the 5-layer versions, is we have to variably deal with these edges. Now notice what I did here. You got what appears to be parity here and here. Well, that's okay, because what we're going to do is we're going to do that parity algorithm to swap these two. And this is going to be what I call the even layered parity, or even number parity. Hold it to where the two centers that need to be swapped are on the right and the left, and then perform this algorithm 2U, 2R, then you're going to go 2F, but you're going to split the 2F here. We're still splitting here. So you're going to split it down here just behind these parities. So 2F, then go 2U, and then do the layer above that 2U, and then just basically reverse it with a 2F. Again, it's over here. Then 2F, 2R, 2U, and you will fix that. So these are now fixed. So basically you've edge paired these, you brought them back in, and that's based on that middle, adjacent edge swap over here, and then you just have to do the parity algorithm to get it out. The next step that I do, once I get the cross here, is then you put the cross in up here. So let's see what lines up. This is up here, okay. And as you can see, this is here, this is not right over here, this is not right over here. What that means now is now that I've created the edges, I'm now pretending like these are one piece. Instead of saying this is the edge and this is the corner, now this is the edge and these are the corners. So what I have here now is an opposite edge swap. That opposite edge swap is the same, is basically the algorithm that goes 2R, 2U, 2R, 2U, 2R, 2U, and you'll get it. So there it is. Now if I were to do an adjacent edge swap using this as my R instead of this, then I'm going to swap these three instead of these one. So it's really just a question of wherever you decide your R is. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. So what I did is I just swapped these three as opposed to the one. If I do the same thing like this, I'll just swap these centers here, because now I'm looking at this as the edge. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. So see what I did is I just swapped these centers here. So however you use the algorithm is how you're going to swap these guys. 2RU, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Swapped these two back. Now I'm going to swap both of these edges here by using this as the 2R, which will swap these in the middle. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Okay, so really it's one algorithm, but we variate our strategy based on what we define as our middles. And again, as you get into the higher order cuboids, 5 by 5 by ends, 6 by 6 by ends, we're going to be variably doing that by changing our definition of what our centers are. Now this is the same strategy that I use not just for the 5 by 5 by 4, but also the 5 by 5 by 6, as you can see over here. As I'm solving the cuboids, as I put this in, I use the same strategy with this last layer here, whether I do it from here or define my R's from here. Same thing with the 5 by 5 by 6, and the same thing with the 5 by 5 by 7, although this acts more like a cube, more like a 5 by 5 as it's a shapeshifter. Once I get it back to where it's supposed to be, then there's always going to be the levels that you have to use the 5 by 5 portion. And now more recently, also applying it to the 5 by 5 by 8, that's this monster over here. The 5 by 5 by 8 is much like the 5 by 5 by 6 and the 5 by 5 by 4 in that it's got odd to even asymmetry. It is not a shapeshifter. This is Klaus and Gregory's great puzzle here, which I'm going to be going over, but it's the same kind of strategy that we'll see. And of course, the 5 by 5 by 9. With a 5 by 5 by 9, as we add that to the family, this one is also going to be solved similarly, only the difference is this one is a shapeshifter, much like the 5 by 5 by 7, just taking it to an even higher order and a higher level. Pretty cool puzzle. Who's excellent. So I'll be just demonstrating this as well. But that's as kind of an introduction to more of the 5 by 5 by n series. And that strategy is going to be used over and over again, so I thought it would be a good opportunity to reintroduce that. So I hope that cleared it up for you. Let me know if not. Thanks for watching. So here's another question, here's another dilemma that was posed. Now I'm not sure exactly what the situation was, but it had to do with the super square 1. which is a puzzle that's very challenging to move, which is why I always hesitate to use this, but I think it had to do with the fact that what the message actually said, or what the question actually was literally is that all the centers were done, but the top corners and the bottom corners were mixed up, and wanted to know how to fix them without messing up the top. So I'm not sure exactly what that meant. I think maybe you didn't want to mess this up and you had these middles in, but this would be a good time to show how to deal with these corners here if everything came in. Now the thing about this is when you solve this is you do a combination of square one strategy and cuboid strategy, in this case 3 by 3 by 4 strategy. So I showed you the algorithm when I was demonstrating this using this guy for middle swapping. All you're going to be doing in this case to get these where they need to be, the corners, is you're going to be doing corner swapping. So here's a similar situation where we're going to want to move our corners into position. What you want to do first when you want to get all the corners in position before you even work on the centers is you want to look to see if there's a corner that I would call the sandwich formation. What I really mean by that is I meant that two corners are appropriately in conjunction with each other, even though the middle is not. Or it could be, but two corners are in and the rest aren't. What you want to do is, if that happens, move this to your left side. Now, another situation is you don't have any that's in. Like in this case, you see a situation like this. When that happens, you just randomly do a corner swap. So when you do a corner swap, that algorithm is 2R, U, 2R, UI, 2R. And then both of the two sides that you're swapping makes a counterclockwise turn. So the top one will do a UI, and the bottom one will do a D. So you pretty much just turn this. Then you go 2R, UI, 2R, U, 2R. What's going to happen is you're eventually going to get a situation where two of your edges are going to be, or two of your corners are going to be in. When that happens, move it to your left side. Make sure it's at your left side. Then do the algorithm again, and it'll put all of your corners in. So this will get swapped to here, and this will get swapped back to here. 2R, U, 2R, UI, 2R. Whole thing turns, 2R, UI, 2R, U, 2R. And as you can see, all of the corners are in. So once you do that, it's just a matter of doing your middle swapping. And there you go, then you just do this. Now notice with this there's no parities that you have to worry about because there's no edge in between, there's no layer in between these two. Coming about this uses exactly the same cuboid strategy. So what I'm going to do is I'm going to look to see, are there two corners that are already in? So as I'm looking, as I'm turning this around, bang, I see these two. The center's in, but I see these two are where they need to be. So if this is the situation that you're talking about, since I see two corners that are appropriately in on a side that's already pretty much where everything is up where they need to be, then you're going to turn this so that this is on the left side. If I said right before I meant left, this is on the left side. And then we're going to do that same strategy. We're going to do the same middle swapping. The difference is that if I just do it like this, I'm going to get out of my cuboid form. So I have to prime it to where you're not going to get out of the cuboid form. This layer is complementary to this layer. This layer is complementary to this layer, which means one layer, the complementary layers have to be primed in conjunction with each other. So if I move this like this and prime this to here, if I turn it, this will maintain its square shape, but this also has to be primed too. So I'm going to prime it like this. And the reason that I'm doing that is so that I can maintain its square shape, but watch, it's the same algorithm. 2R, and I'm just moving the top here because that's what I'm changing. U, 2R, UI, 2R. Now these two layers, just these two layers, are going to do that counterclockwise rotation. So this is going to be a UI, just this layer, then just this layer is going to be a, without this moving on me, D, and then finish up our algorithm, 2R, UI, 2R, U, 2R. So as you can see, it now put all of these in, so that solves it appropriately there. I think that might be what you mean. If not, let me know, but that's how you maneuver the corners. You're just doing that kind of strategy. Here's another possible situation that you might be referring to. This is a situation where, again, these two are solved, but you need to move the corners appropriately. In other words, this corner is not where it needs to be. You want to move it down here. Maybe that's what you mean. To do that, then you're going to do a corner switching algorithm, where just like here, I've got the yellow one here, I need to move it down over here. This is red and green. This has to come down to here. So the algorithm to do that is you position this just above where it needs to go. So this needs to come down to here, and that's going to be 2R, U, 2R, UI, 2R. And that'll swap that. So let's take a look and see if, just in case that's what you're referring to, I can see that this green, yellow, and orange needs to come down to here, where I see orange and green. So that's got to come over here. So same kind of thing. Let's prime it so that we can maintain our cube form. These two layers have to be primed in conjunction with this. And now what this is going to do is move this down to here. So this should be where it's supposed to be. So again, it's the same algorithm. 2R, U, 2R, UI, and 2R. Okay, so what that did is that did in effect put this down here. You can see these middles kind of got, there's kind of created a quote parity between these two here and also these two over here. So we need a way to kind of get out of this situation over here. To do that, it's kind of a unique way of doing this. To get out of this situation, what we're going to want to do is the equivalent of an adjacent middle swap. But in this case, the middle is not these guys. The middle is this. So, no, I'm sorry, the opposite middle swap. So that's going to be 2R, 2U, 2R, 2U, 2R, 2U. Huh? Pretty cool, huh? So that's really the best that I can do, I think, answer the question about how to deal with these corners. In this case, if you manage to get it back into the cuboid shape, if you manage to move things in the appropriate level, you've actually done the hardest part. The rest is applying cuboid strategies to your super square one. Let me know if that is what you need or not. Hopefully it helped. Now, what I'm going to do is, since I've tried to answer some of your questions, I'm going to have you answer one of mine. So here's my challenge. Here's my question. My question is, what is this? What puzzle is this? How is this put together? How is this configured? So it looks like a normal 3x3, but it isn't. So I'm going to just kind of move it in various positions, and you will tell me what you think it is and how I solved it. So I'm just going to move certain areas here. So here's the bottom. Moves pretty here. Uh-oh. And I'm just going to scramble it. So how is this put together? What is this all about? What's going on with this? And now after doing a scramble, what I'm going to do is I'm going to solve it. And somewhere with the solving, see if you can figure out exactly what the deal is with this puzzle. And you're just kind of paying attention to see exactly how I'm doing what I'm doing. And this actually fits the theme that we've been talking about, believe it or not. Fits into that theme. And I'm going pretty slow for the purposes of illustrating. Okay, so what was this? How is this puzzle put together and how did I solve it? Let me know your answer. Thanks for watching.